Drying of food.
Hi guys, I'm Kijun from Group Good Juice Bar. Let's begin our lesson. What is drying? Drying is also known as dehydration. It is one of the oldest food preservation methods. So, how does drying preserve food? It applies heat to remove most of the water from food product so that the microorganism can't live on the food. Hence, it can prolong the food shelf life. It usually uses dry or hot dry air. As you can see, there are three categories of drying method, which are contact drying, freeze drying, and vacuum drying. First one is the contact drying. It is an indirect method of removal of moisture from the solid by application of heat, such that the heat transfer medium is separated from the product to be dried by a metal wall. So here is the picture to show one of the example of contact drying equipment, which is called the cylinder dryer. The wet food will pass through the heated metal to remove the moisture. The second category is freeze drying. Freeze drying is a low temperature dehydration process that involves freezing the product, lowering pressure, then removing the ice by sublimation. The last category is vacuum drying. It uses hot air for evaporation and to carry away the evaporated moisture from the food product. Next, we are going to learn about the principle of drying. It is a simple principle. It involves the transfer of heat to provide the necessary latent heat of vaporization and also the movement of water or water vapor through the food materials and then away from it to effect the separation of water from the food stuff. So now, let's see what food that's commonly applied the drying method as the way of the food preservation. Its common application are milk, spices, fruits, flour, tea, coffee, sugar, and so on. After this, we move on to the phase diagram. This is the phase diagram of water. The change of state for water commonly classified into three, which are solid represent ice, liquid represent water, and vapor. The state of water is determined by the chosen pressure and temperature, as you can refer the phase diagram. So along the line, you would see there is a point where all the lines intersect, which is called the triple point. It is a point of combination of pressure and temperature that facilitates all phases of matter at the equilibrium. The temperature and the pressure for the triple point of water to be occur are at 0.0098 degrees Celsius and 0.64 kilopascal. Based on the phase diagram, you can see there are three curves. The first curve is called the sublimation curve, which represents the transition between gaseous and solid states. The second curve is called the fusion curve. It represents the transition between liquids and solid states. The last curve is called the vaporization curve. It represents the transition between gaseous and liquid states. If heat is applied to water in any state at constant pressure and the temperature is increased, it will cause a change of state. Now we look at the line A to A prime, which is the orange arrow. As you can see, the pressure constant, which let's say the A point A is the pressure, and when the temperature increases, move along the line, and we can see the state of water change from solid to liquid to vapor. Alright, now let's look for another example. Please look at the line B to B prime, which is the blue color arrow. So at this pressure, let's say point B now is the constant pressure and the temperature increases. So for this case, the state of changes will be from the solid to vapor.
Now, turn to mechanism of drying. Basically, drying is occurred when hot dry air pass over wet food surface. Latent heat of vaporization will cause water in food to evaporate. The mechanism of drying is fully explained by this diagram. When hot air is blown over a wet food, heat is transferred to the surface and latent heat of vaporization will cause water to evaporate. Water vapor will diffuse through a boundary film of air and is carried away by the moving air. This will create a region of lower water vapor pressure, and hence gradient is established from the moist interior of food to the dry air. The gradient will provide the drying force for water removal from the food. Next is turn to drying curve. Normally, drying curve will plot the drying rate versus drying time or moisture content. There have three major stages of drying can be observed in drying curve, which are transient early stage, which represent the period when product is heating up. Second, constant rate period. Constant rate period is the period which the moisture is easy to remove. Last, falling rate period, in which moisture is bound within the solid matrix. This one. Next, these are the example for drying curve. We may observe clearly that the left-hand side one consists of leg phase lag period here, but the right-hand side doesn't consist of lag period. So now, turn to the diagram below. We can clearly observe that they have three categories. First, constant rate. What is constant rate? In constant rate period, the water is being evaporated from what is effectively a free water surface. The rate of removal of water can then be related to rate of heat transfer if there is no change in temperature of material, and therefore all heat energy transferred to it must result in evaporation of water. The rate of removal of water is also the rate of mass transfer from the solid to the ambient air. These two means mass and heat transfer must predict the same rate of drying for a given set of circumstances. This is the explanation for constant rate period. Now, turn to first falling rate period. Actually, what is falling rate? We can observe they have divided into two, which is first falling rate and second falling rate. What is falling rate? Falling rate is reached when the drying rate starts to decrease and the surface water fall to less than 1. The first falling rate is occur when wet spot is surface continuously diminish until the surface is dry. First falling rate in both diagrams can be represented by B in the left hand side diagram and C in the right hand side diagram. This is the first falling rate. Next, what is second falling rate? Second falling rate is begin when the surface is completely dry. The plane of evaporation recedes from the surface, which can represent by C and D. Next, now we may wondering what is critical moisture content. Critical moisture content is the moisture content at the point when the drying period changes from a constant to a falling rate. The drying behavior of food material will depend on porosity, homogeneity, hygroscopic property. What is hygroscopic property? Hygroscopic property actually is the one that readily attracts water from its surrounding through absorption or absorption. Hygroscopic food material will enter into falling rate faster compared to non-hygroscopic fruit material. In hygroscopic fruit material, there have more than one falling rate period occur. This may represent by the graph now. Okay, we may observe that there have only one falling rate in this graph, which is for non-hygroscopic material graph, and they have two, first one and then the second one, falling rate in hygroscopic material graph. Falling rate period is the longest period during drying of food product. Equilibrium moisture content, which is EMC, occur when dry spot develop at the surface, so less area exposed to dry air and evaporation decrease. EMC is this one, equilibrium moisture content.
Next is cyclometrics. Psychrometrics is the study of interaction between temperature and air humidity. Capacity of air to remove moisture from food depends on, first, air temperature, second, evaporation rate, which equals to temperature plus relative humidity, third is water vapor that already removed. There are some important words in psychrometrics. First is moisture content, or known as absolute relative humidity. It is the mass of water per mass of food. Second is equilibrium moisture content. It is the moisture in food equilibrium with drying air. Third, the percentage of relative humidity, also known as RH, is the partial pressure of water vapor in the air to that of saturated water vapor at the same temperature. As you see in the diagram, the first one is a dry bulb temperature and the second one is a wet bulb temperature. So what's the difference? For dry bulb temperature, it is the temperature read by a thermometer. For wet bulb temperature read by a thermometer which bulb surrounded by a wet cloth. Like in this diagram, is surrounded by the wet carton. So for dew point, it is the point of saturation, means that it is 100% relative humidity. The relative humidity, RH, of air can be found on a psychrometric chart using difference between dry bulb and wet bulb temperature. Next, we will proceed to classification of psychrometrics. Psychrometrics is classified into two categories. First is hygroscopic and second is non-hygroscopic. Hygroscopic means that partial water vapor pressure varies with moisture content. And as for non-hygroscopic, it means that constant water vapor pressure at different moisture content. For classification of dryers by drying processes, it is also classified into two categories. First is adiabatic processes and the second is non-adiabatic processes. So what it means by adiabatic processes? It means that the heat of evaporation supplied by sensible heat of gas is in contact with the material. The examples for this kind of process are particles drying and batch or bed drying. Second, non-adiabatic processes. It means that the heat of evaporation is supplied by radiant heat. The examples are vacuum drying, purge drying, and radiation drying. So that's all from us. Hope you guys enjoyed our video. Do remember to like and comment on this video. Thank you!